Welcome back to Math 109 Plain Trigonometry. In this video, we're going to take a look at converting a number from the rectangular form to the polar form. So if I give you the complex number, negative square root of 3 plus I, we want to convert this into polar form. Now, the first thing we're going to want to do is at least have an idea of where that's located on the graph. So I'm going to draw my coordinate plane again, with the x-axis being the real axis, and the y-axis being the imaginary axis. And we're just going to think about what's positive and what's negative. So in the first quadrant, the real part is greater than 0, and the imaginary part is greater than 0. Second quadrant, the real part's going to become negative. So the real part is less than 0, but the imaginary part is still greater than 0. Third quadrant, both x and y are negative, so the real part is negative. Imaginary part is negative. Fourth quadrant, the imaginary part is still negative, but the real part is now positive. So we know that theta, in this case, because we have a negative real part and a positive imaginary part, so that would be this case here. So in this case, theta is in quadrant 2. So now, we're going to need to find r and theta. To find r, that's simple. We just plug it into the formula. R is equal to the square root of minus the square root of 3 squared plus 1 squared, which is equal to the square root of 3 plus 1, or the square root of 4, which is 2. We do not need to worry about plus or minus here. We always assume that a radius is going to be positive. Now, a little bit more work that we have to do to find theta. We know in this case that the tangent of theta is equal to y over x, so the imaginary part over the real part. So we get 1 over minus the square root of 3, which I can rationalize the denominator on that and get negative square root of 3 divided by 3. So now I need a reference angle that has a tangent of square root of 3 over 3. So that would be 30 degrees. So our reference angle is 30 degrees, and we've already established theta is in the second quadrant. So that's going to tell us that theta is equal to 150 degrees. Now, the final caveat that we have with this is generally, and the textbook doesn't always operate this way, so with stuff on the study plan, make sure you're paying attention to what it's asking for. But generally in higher mathematics, we want to work with this theta being in radians rather than degrees. So we'll go ahead and make that conversion. Multiply by pi radians per 180 degrees. And that is equal to 5 pi over 6. So we can now write our complex number as 2 And then I'm going to use that CIS notation that I introduced in the last video. 5 pi over 6. So that's how you write a complex number in trigonometric form. That's going to do it for this set of lectures. The next set of lectures, we're going to take a look at how we can use this trigonometric form that we just established to make multiplication and division of complex numbers a lot simpler than it was before.